to being ready. I just haven't taught you everything yet. All right, ribose. There's ribose. Okay, it's a sugar molecule in RNA. Is this molecular or empirical? Molecular. It's telling you exact number. It's a multiple of an empirical. So this one is molecular. I'm going to put an M. Ethyl butanoate, a compound with the odor of pineapple. It's actually very delicious. You know, like when you buy those stickers that you scratch or whatever, that's what you're smelling. You're smelling some sort of chemical compound. You're not smelling actual pineapple or peppermint or blueberry or raspberry or cherry or whatever. Okay. Look at this compound, C6H12O2. Stop talking now. Molecular or empirical? Molecular. What's up, Megan? Oh, good. All right, what about this one? This is chlorophyll. Molecular or empirical? Empirical. I'm just going to put an E for empirical. C12H17ON. Empirical. Easy peasy. And then finally H2C2O4, which is oxalic acid. That's molecular. Okay. Then it says calculate the empirical formula for each compound with the following percent composition. I think I'm going to need a skinnier pen. So how do we do this? We're going to turn the percent to grams. Good. Stop talking. 94.1 grams and 5.9 grams. This is oxygen. This is hydrogen. We'll just keep them labeled. After you get that into grams, then what are we going to change it to? We're going to change it to moles using the gram formula mass. So, moles equals grams over gram formula mass. 94.1 grams. What's the gram formula mass of oxygen? 16. And that's going to give us a whopping 5.875. Yeah. Okay? We're going to round it to 5.9 moles of oxygen. Keeping it labeled so that we know what the heck we're doing. Now let's do the hydrogen. We've got 5.9 grams of hydrogen divided by 1 gram per mole of hydrogen. That's going to give me 5.9 moles of hydrogen. These two numbers are my mole ratio. So I've got O and H. We have O, which is 5.9, and we have H, which is 5.9. This is not empirical because it's not the lowest whole number. What do you call a whole number in math? A real number, an integer. Okay, I saw that word come up and somebody's like, you didn't teach us integers. Integer just means whole numbers. Okay, so 5.9 and 5.9 we're going to divide through by the smallest one, which happens to be 5.9. And you're going to end up with OH. That's the empirical formula with those percentages. Okay? All right, let's do the next one. I'm just going to move this up here so that we have room. 79.9% carbon. That's going to give us 79.9 grams of carbon and 20.1 grams of hydrogen. We're going to change them to moles by dividing by the gram formula mass. 79.9 grams divided by 12 grams per mole. Does everybody know where I got the 12 from? Okay. So what is 79 divided by 12? 6.7. Okay, 6.7 moles of carbon. Keep it labeled. Now let's do 20.1 grams of hydrogen divided by 1 gram per mole. That's going to give us 20.1 moles of hydrogen. Okay, so here are our numbers. This is my mole ratio, moles to moles. We've got carbon, which was 6.7, and hydrogen, which is 20.1. We're going to divide through by the smallest number, 6.7, 6.7, and you're going to get C1H3. That's my empirical formula. Capiche? Okay. Number 3. I think I have it on the next page. Yeah, there we go. We got apples. Something that smells like apples. It's right here. Yep. We're on number 3 on that side. The side you're looking at. Its percent composition is 58.8% carbon, 9.8% hydrogen, and 31.4% oxygen. So let's take the 58.8, change it to grams of carbon, 9.8 grams of hydrogen, and 31.4 grams of oxygen. We're going to change them to moles by doing what? Divide by the gram formula mass. Everybody good? It's the same process every single time. What's 58.8 divided by 12? 4.9. And that's moles. 9.8 divided by 1, even I can do that in my head. 9.8 moles. And 31.4 divided by 16, 1.96 moles. Okay? There's my mole ratio. Moles, moles, moles. I'll do it over here. So that means carbon is going to be 4.9, hydrogen is going to be 9.8, and oxygen is going to be 1.96. Is that the empirical formula? No, we need to make it lowest whole numbers. So we're going to divide everything by the smallest number, which is 1.96. And 4.9 divided by 1.96 is going to be 2.5. Hydrogen is going to be, oh, I don't remember. 5, thank you. And oxygen is going to be 1. Now, is this an empirical formula? No, because you still don't have a whole number. So to get rid of that half, we can't divide by the smallest number again, because the smallest number is 1. We have to double everything. So we're going to end up with C5H10O2. Well, yes. So what we did now is we found the empirical formula, correct? Okay. Then it says, if its gram formula mass is 102 grams per mole, what is its molecular formula? And remember, the molecular formula is any multiple of the empirical. So let's find out how much this sucker weighs. We've got 5 carbons at 12 apiece. 60, thank you. I don't know what I wrote, 70. H, there's 5, there's 10 H's times 1. That's why I got 70 before. I was doing it in my head faster than my pen. And then, again, oxygen, there's 2 at 16, which is 32. Okay? So if we add all these up, we're going to get 102 grams per mole. That's what we're looking for. Something that weighs 102 grams per mole. So this, not only is it the empirical formula, it is also the molecular formula as well, because the gram formula masses match. Let that sink in for a second. Because an empirical formula is the lowest, and a molecular formula is any multiple of that empirical, including the first one. And this one happens to be the first one. Okay, I told you to skip number 4. What's up? You could do it that way. It's just going to take you a lot longer. Okay? But it will work. All right. A compound of carbon and hydrogen has the composition, this is the last one now, 92.25% carbon. So I'm going to change that to grams, and for space-wise, I'm just going to put grams of carbon. And then I have 7.75 grams of hydrogen. Okay, what am I dividing the carbon by? 12 grams per mole. And hydrogen gets divided by 1. We like that one because that's easy. Okay, 92.25 divided by 12 is 7.68 moles of carbon. Keep it labeled, bless you. Keep it labeled. 7.75 moles of hydrogen. Oh, those are pretty close to each other. It looks like we're going to get to 1 to 1. Okay, C, 7.7, and H, 7.75. We'll divide both by 7.7. Can you understand that that's 1? I don't have to write it down? Okay, so C1H1. There's the empirical formula. It's not a half, so it's close enough to this 1 that we can make it 1. Now, if the compound has a mass of 52, what's its molecular formula? Well, what does this CH weigh? It weighs 13 grams per mole. That's the gram formula mass of CH. How many times bigger is the 52 than the 13? 4. Good. So 52 divided by 13 tells you that 52 is 4 times bigger than 13. So then the empirical formula has to be C4H4. Now let me just bring something up that came up last period, and I thought it was a really good question. Somebody said, well, I wrote the answer, and that's the answer, C4H4. And somebody said to me, why can't you just write 4 CHs? What's the difference between this and this? Nope. Well, which one are you talking about? No, just keep going. Go ahead.
CH is like maybe a different compound.
It is a different compound.
For the one on the right, it's like, it's not one group has 4 carbon hydrogen. It's 4 groups of a carbon and hydrogen.
Good. So you have CH, and you have CH, and you have CH, and you have CH. It's 4 groups of CH, whereas this one is CH4. Maybe you've got 4 hydrogens sticking on there. Something like that. 1 group of C4H4. And this is 4 groups of CH. See the difference? Is that what you were going to say, Charlie? Good. Nora, you see the difference? No, you got it? What are you doing? Just looking. Okay, any questions on empirical and molecular formulas? Going from the formula to the percent, it's on your midterm. Going from the percent to the formula. Any questions? You got that. You know what an empirical formula is. You can match an empirical formula to a molecular formula.
Yeah.
If they give you 2 things and they say which of the following is paired empirical and molecular together, you have to look one that's a multiple of the empirical formula. Right? So if the empirical formula is CH2, is C2H8 correctly paired with this empirical formula? No. This would be 1 to 4 ratio. This is a 1 to 2 ratio. See the difference? This is not the empirical formula of C2H8. The empirical formula CH2 could be C2H4. It could be C3H6. Anytime you have a 1 to 2 ratio. See that? Okay. All right, let me shut this video off.